Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I am really excited to introduce our guest for today, Tom Chepucavage. He is the CEO of Flow Aluminum. Welcome to the show, Tom.
Thank you, Lisa. I appreciate the opportunity.
Absolutely. It's so great to have you here. Maybe we can start by having you give a little bit of background on yourself and Flow Aluminum.
Sure. So my background is in management consulting. I began my career with Accenture, and then I worked in utilities and for a logistics company that served the battery industry. And I met this team through a technology transfer office at the University of New Mexico.
Oh, cool. Wow, that's amazing. So tell me a little, just kind of super high level about Flow Aluminum.
Sure. So in the technology transfer program, we had an accelerator. I saw Christy Fetra, the PhD that wrote the patent, was Dr. Wei. I saw them pitch at a competition and win. And this combination of the sustainable battery with the direct air capture capability really won me over. And then immediately they paired me with Christy to do this accelerator, do market research. And so, we just grew from there. We incorporated in May of 2023. The original research came out of MIT. Dr. Wei did a postdoc there, and then we wrote the new patents in Albuquerque at UNM.
Wow. Okay. This sounds so incredibly cool. So tell us about the major problem that Flow Aluminum is seeking to address.
Yes. So lithium has an incredibly, complex and dirty supply chain. It's expensive to recycle. It's flammable, and geopolitically, we have an international supply chain. And so Flow Aluminum, our batteries, the aluminum CO2 battery addresses all of these. We have a domestic supply chain. There's no thermal runaway. It's not flammable. And aluminum is very abundant and highly recyclable. So.
It's the perfect solution. So how are you making the battery energy storage systems, or BESS, more efficient and sustainable?
Sure. So we are a BESS, and we're actually LDES, a long duration energy storage solution, which is where the industry is moving. The Department of Energy defines that as 10 hours and longer. And so we are at that threshold, and we could potentially go, up to 100 hours. And so, the industry is growing. Tesla's, most of their earnings came from the Tesla Megapacks, their BESS solutions. They are not LDES, and they are sourced from China. But it's growing just amazingly fast, and we want to take advantage of this growth.
How did you manage to get your full supply chain in the US? That is a really unique thing, especially given all of the changes that we might be seeing coming up here.
Yes, the tariffs will be interesting. We've been working with Rio Tinto and Drumlin Capital, and there really is just an abundant supply of aluminum. So Rio Tinto and Drumlin for the aluminum, and then PBS Chemicals out of Michigan for our electrolyte, the ionic liquids, and then carbon paper is abundant, and there's a lot of alternatives for that. That's our cathode, the catch and black and other carbon sources we can source domestically, so including the separator. So being that aluminum is so abundant, and our resources with PBS Chemical, it's a fairly simple supply chain.
That is amazing. So are these systems lighter than like a typical lithium battery, or?
Yes, the aluminum CO2 batteries are lighter. They have larger volumetric density. We are using pressurized cylinders that are slightly larger than lithium batteries, which is why we are targeting LDES, the grid storage, because it's less of an issue there versus putting a larger battery in a car, in an EV. However, we would be lighter there. But so that's kind of the reasoning for the grid storage.
Yeah, yeah. So how else is this technology different from the technologies that we typically use today for battery energy storage systems?
Yes, so we actually perform really well at extreme temperatures, down to -40 Celsius. We had a grant to test to -60 with NASA, and then up over like over 100 Celsius, the battery can perform at levels that lithium can't even compare to. No other battery technologies can compare to. And then another, we have 100% depth of discharge. Lithium batteries, typically you can only discharge 80%. We can go to 100. We could store the batteries completely discharged for a year and then bring them back and recharge them. And then we actually, in the flow battery format, we have two formats: a sealed battery in a cylinder, and then a flow battery, which flows electrolyte over an open electrode that concentrates ambient CO2, which is like a direct air capture. So we're actually pulling carbon out of the atmosphere, as you've probably seen funding and a lot of news about capturing carbon out of the atmosphere.
Yeah.
This is actually a really unique value proposition. So we have two products: a battery, a flow battery, and the CO2 capture, which is really what drew me to the product.
Wow, that is amazing. So, do you not experience some of the same issues that you have with lithium in terms of that sort of being able to charge and recharge that battery and sort of that loss of capacity?
We have zero degradation over the test cycles we've done. We're around 700. We want to hit 10,000 just physical cycles to see, but so far we've got no degradation. And then in the testing below zero, actually down to -30, our performance actually increases. Where way higher than that, lithium just really goes off a cliff and just degrades. And you've probably heard in Chicago and other cities the issues with the EVs and the lithium batteries. And grid storage, Canada and Northern Europe has struggled with lithium grid storage, and we solved these and open up new markets. Arid, we could be in Sahara Desert or up in Northern Canada and perform very much better than lithium batteries.
Wow. Okay, this is so exciting. So, what are some of the primary use cases for this?
Yes. So residential storage, industrial uses, and grid long duration. So large 200, 600 gigawatt, 1 gigawatt battery farms. Uh, we can actually use it in a microgrid. Actually, with the military, we're looking at in submarines, because we have no thermal signature or no acoustic signature, because with no thermal runaway, no flammability, we actually don't need the fire suppression, which makes a lot of noise and is a lot more expensive, and that's another cost savings. So yeah, residential, industrial, and grid storage with utilities, submarines, submersibles, and we do have some space applications, and we are looking. We could actually work with a large truck EV. We could actually work with large vehicles and boats, cargo ships as well.
Wow, amazing. So, we won't necessarily see these in like our EV cars.
Yeah, not at this time, because with the cylinder formation, it's too large. It would take up too much room
Got
in
it.
a sedan.
Okay, understood. Interesting. Okay, so what are some of the most unique or interesting use cases that you see potentially coming up?
So interplanetary Mars, actually, the atmosphere is primarily CO2. Our flow battery, reacts with ambient CO2, so it would take that atmospheric CO2 and drive the battery kind of in perpetuity. So it's the ideal battery for Mars for interplanetary travel. So that's kind of the most unique application, and so it's really exciting to see, where SpaceX or these companies, if they're going to reach Mars, and we'd hope to be on those first missions.
Oh, wow, that's really exciting. Okay, so where are you in the development process? Can we get these solutions today?
So not yet. We should have our power core, the initial 150 amp hour cylinder, within the next year. If we can secure funding to staff up significantly in the near future, we could probably bring it in to 6 months. But right now we're about a year out on the core cylinder that's modular, which means you can stack and rack it to any capacity you want. You could put 1,000 of them in racks and get, a 3 megawatt hour battery, or you could have the 1 amp hour battery driving, a residential, a small home. So that's practically a year to a year and a half out, unless we can significantly staff up.
Gotcha. Well, you know what? Time goes very quickly, so that's really right around the corner.
Yeah.
So, tell me a little bit more about kind of what is the size of, I guess, a single unit, or what do you call, kind of tell me a little bit about kind of what you call a single unit and how large a single unit would be.
Yeah, so it's practically the size of a scuba tank without the rounded ends. So
Okay.
that 150 amp hour battery, it's about 1.3 volts, so it is lower voltage than a lithium battery, but we can address that with software and other configurations. So if you picture a scuba tank that is modular, that you can rack and stack hundreds to 1,000 plus of those to get a bigger, to get to the long duration energy storage solutions.
Okay, got it. Okay, so I I want to move on to a question about the future. So, if you were to make one prediction about the future of sustainable energy solutions, what would it be?
So I see, in particular with grid, a hybrid environment where we have solutions that are hydrogen based. We have sodium batteries. We have aluminum batteries. We've got thermal. We've got compressed air. These cement blocks that you use some sustainable energy to lift up and drop. I think there's going to be a broad variety of solutions that will all be more sustainable. I do think we'll be moving away from lithium to the alternative batteries, iron flow batteries, zinc, bromine, these types of batteries that are not flammable and more sustainable.
Okay, well, it sounds like an exciting future. I can't wait. So, if
Yeah.
someone wanted to learn more about Flow Aluminum, what should they do?
Our website, we just did a big update with a lot of information. It's www.flowaluminum.com, FLOWALUMINUM. And then we do have significant presence on LinkedIn. We have a company page there. And so those are the two primary, but feel free to reach out. I'm at tom@flowaluminum.com. Happy to answer any questions. And our lab is in Albuquerque. Feel free to stop by anytime. And we'd love to engage.
Excellent, excellent. Thank you so much for making time to be here today. This is a really exciting technology. I cannot wait until it is available.
Thank you, Lisa. I appreciate the opportunity.
Absolutely, my pleasure. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.